Hello friends, welcome again. So let's get started with subqueries. Subqueries. So what is a subquery? What is a subquery? As the name suggests, it's like a query within a query. A query. So what is a subquery? A query within a query. And I do not know if there is an official definition to it, or nor I am reading the official definition. I am saying what my mind says, right? A query within another query. So might be we are writing, let's say, a query one, and inside this we are using a query 2. Inside this we are using a query 2. So it can be that, let's say, inside this we are even using some query 2, let's say, right? So query 1 becomes the outer query and query 2 becomes the inner query, right? So in the above, query 1 is the outer query and query 2 is the inner query, right? And you do not worry if you cannot understand the definition, because all what makes sense is to understand it practically. No one will ask you a definition, right? So let's start with the practicals, right? The best way to learn SQL is do the practicals and do not worry about definitions. Okay. So let's say we have solved this problem earlier also, but now I will show various approaches to solve. There is a customers table and an orders table. Orders table. There are two tables, let's say customers and orders, right? I want to find all the customers who have not placed even a single order. Find all the customers who have not placed even a single order. That means this customer has registered but not placed a single order. For example, like you might have registered on Amazon, but you have never placed the order. That kind of scenario we want to see. Might be inactive customers or customers with not generating any value to the company, kind of that way. How do you approach this? I have the database with these six tables: orders, products, order items, department, customers, categories. But what I am interested in right now is the customers and orders table. Right? I will run this again just to show this is the current view. These tables I have because I ran that create DB script, right? So I have these six tables with me right now. But I'm interested in customers and orders. So now, how do I approach this problem? You might say, Sumit sir, we have solved that earlier using a left outer join and all. Yes, we have solved. There can be multiple ways of solving a problem, and I will show multiple ways to solve this now. Right? So what we want to find? Find all the customers who have not placed even a single order. And let me just make the language as SQL view syntax, and I can say SQL. Okay, yeah, should be fine now. So let's start. The first solution that I will show you is with a subquery so that you understand what it is. So what I want is select star from customers. That means I want something from customers which is not there in orders table, right? Which is not, I want customer IDs from customers which is not present in orders. So this customer ID should not be present in orders. So I'll write it here. Logically, if you think, you need customer IDs from uh, customers table which are not present in orders table, right? Which are not present in orders table. That's what we want. So I can say select star from customers where, so I will just first of all see what is there in customers. Select star from customers and I will even say select star from orders. Let me have these two data sets for me to see. So this is the customers data set and this is the orders data set. So in customers, I have something called as customer ID. So I'll just write it. In customers, what do I have? Customer ID. Right? In orders, what do I have? In orders, how do I say this is for a customer? Order customer ID is the column. Order customer ID. Okay. Now I want to get records from customers where where what I want customer ID. Select star from customers where customer ID not in, not in, right? Not in, and then what I want that okay that if it is not there in the orders, that means if I take a list of these, right? I mentioned 11599 256 because these are there in orders. So if I give a list like that, 11 let's say 599 comma 256 comma, right? 12111 like that. But I cannot type it, but you kind of got a gist what I am trying to say. That means these are customers who have placed order. So I want customers who are not in this list. Not in this list means they are not there in orders table. But I cannot manually type in the values for who is there in orders, right? There should be a way to mention that. And how to get customer IDs from orders. So how do I know customers who have placed the order? They are there in orders table, right? So how do I know which customers are there in orders table? I can say select order customer ID from orders, isn't it? These are the customers who have or who are there in the orders table. So if I take this and put it here, if I take this and put it there, what I am trying to say then, right? What I am trying to say, I will just put it here and then you will understand. So I am trying to say I want all the customers from the customer table who are not there in the orders table, right? You can see this. And if I run this, I will get all customers who have never placed any order. So don't you feel that this we are writing another query, right? Inside this one. So what is the outer query? This. And what is the inner query? This one. So which one is executed first? The inner query gets executed first. That means first it will execute this and it will get all this 11599 256 12111 8827 like that, right? And this will be replaced with the output of this, right? And then it will say select star from customers where customer ID not in this. That's how it will execute. And if I run this, you see it is giving me 30 such customers who are not there in orders table, right? So we are getting 30 such customers. Customer ID 219, 339, 469, 1187, and so on. There are just 30 such customers who have never placed any order, remaining have placed. So I hope you can understand this well. So this is using a subquery approach, right? So what gets executed first? The inner query. This is the inner query which gets executed first. And then the outer query. So when this is executed, it will be replaced with something like where not in one whatever, right? For example, if you see, it will be replaced with 11599 256 599 256 comma like that all the values, and then it will try running this. I hope this is clear. So I will just do a control Z so that this is our query. Now, are there any other ways? So I understand the topic is subquery, but I want to show you that it's not that that you will be able to solve it with only subquery. Sometimes it becomes essential to solve it with subquery only. There might not be any other way, but ideally we can do the same problem in many ways. So subquery was one of the way here. We could have done it in some other way also. So how to do that? So let's say uh, you have customers table on the left, let's say, right? And you have orders table on the right. So you want records from the left table which are not there in right. So you always remember, I have mentioned it many times. In such cases, when you have a requirement that something which is there in left table but not in right, you can always do a left join, right? Left outer join. And after doing that, you check for nulls on the right. Right? Check for nulls on the right. Check for nulls on the right. That means records which are present in left table but not in right. That's how you will get it. So let me show how to write this query using left outer join. Left outer join. So what I can do is select whatever from which table, customers. C, I am giving alias left join orders O on C dot customer ID equal to, in orders it is order customer ID, right? Order customer ID. So this will give me all the matching records plus non-matching records, right, on the left side. So that means none of the records from the left side will be eliminated in this case, whether there is a match or not, right? Now what I can do, I mean, I can, let's say I just want customers only. I can, whatever column I want, I can select. Let's say I just want to print the customer ID. That's fine. Okay, on this. Now I want which are not present on the right sides. So what I can do, where O dot, this one, right? O dot, this is null, right? Left outer join, and on the right side we have null. So if I run this and if syntax is all fine, I should be able to get all the 30 records. So you can see it is giving me 30 records. You can see 30 records it's giving me. I will clear this, but we are getting 30 records. I will again show that. You can see, right? Okay. So I hope this is clear. Now I could have selected more columns, whatever I want. That's not a problem at all. But I just selected customer ID in this case. I could have done a select star or whatever I want. I could do that and I will get all the columns from both the tables, right? But important thing is it gives me 30 records, right? Okay. So if I want only, so you know that since whatever query we are writing from right side, we will get null only. Of course, you see this. So what if I want only records from the left table? C dot star, right? So better is C dot star. And this is equivalent to this. This and these results are equivalent, right? Okay. Now, is there any other way of solving this problem? So we have done subquery, we have done a left outer join. Now we could do it using the set operations also. You remember we have this except which acts like a minus. So for example, if we are having customer ID, let's say for example 1, 2, 3, 4, 5 in first table, customer ID, let's say, and in the second table we have 2, 3, 6, 7, and let's say 2 is coming multiple times, 3 is coming multiple time, like this. So let's say this is your customers table, and this is your orders table, and I have written customer IDs in here and order customer ID here. Now if you do a minus between these two, minus or except, right, except, then what I will get? So customers this except this, right? That means it's acting like a minus. So whatever is present in this table but not here, right? So it will give me 1, and it will 2 is there, 3 is there, 4, it will give me 4, and it will give me 5, right? So you can see it will give me 1, 4, and 5. All whatever is there in customers but not in orders, right? And whatever extra is there in orders doesn't matter. See, comparison is with customers, whatever is there in customers but not in orders, that's how we will say it, right? Give me all the things from customers except these things, right? So we can do this also. In this case, what we can do is we can use except, and in some other databases it might come up with minus keyword, right? So I can say select customer ID from customers, okay, okay, except select order customer ID from orders, right? Now you have to remember, you cannot give two columns here and one column here. No, I mean the number of columns and data type should match, then only this will work. Otherwise you don't expect this to work, right? So if I run this, what I'm saying, give me all the customer IDs from customers which are not there in the orders table. That's what how I will interpret. So you can see I can run this, okay, and you remember this will give show that that's fine, but this will work, and you can see I'm getting 30 records. I'm getting the 30 records. But the thing here is, I mean, in the earlier case, you did a select star and all, right? Here you cannot do that. Here you cannot do a select star like that because you can compare a column only, right? So you get all the customer IDs. I hope this is clear. Just have a look. Okay. Now, I mean, in case if you want all the details of these customers, you can wrap it inside a subquery. You can say select star from customers where customer ID in, and then you have this customer ID in this, and this give you a list of customer IDs, isn't it? Just have a look what I am trying to do here. And if I run this, so you can see we are still getting these 30 records, right? Just have a look. We are getting that 30 records. I hope you can understand what I am trying to convey here, right? I think this should be all clear to you, and you can understand that this is working all fine, right? Okay. So now you understand this except also. Uh, is there any other way of solving the same problem? All customers who have never made a purchase. So we can do it using not exist also. I'll talk about exist and non exist later, but I will give you an idea here. Not exist keyword. So it's more like not in, kind of, but slight differences. But I will just show you that. Select star from. So I will just take this one and modify that. Select star from customers. Let's say I will say C, where where uh, instead of customer ID not in, I will say where not exists, and I will say select whatever from orders O. I'll explain you, do not worry. Orders O, where O dot order customer ID equal to C dot order C dot customer ID. Right? First of all, I will see whether this works or not, and after that, I'll explain you this. I'll correct this. Some syntax. Select star from customers. See where not exists. Uh, where not exists. Select star from. Okay. Okay. You can see this, and we are getting 30 records. Now, do not get confused. So you can see whenever you see that we have written another query, that means we are doing a subquery here. Here also it's a subquery. Just like we have done in the very first case, this is a subquery, this is also a subquery, right? But it is slightly different. It is slightly different. Now, if I show you this particular query, if I show you this particular query, right? And I just run this part. I am just selecting this inside subquery part. Will it run? You can see this is giving me all more than 50,000 records, right? You can see I am running the selected part. That means I am able to run this subquery independently. This query or subquery is not dependent on anything, right? I am able to run this independently. If you see this, right, and I remove everything and just put this subquery, I'm able to run this. Of course, I will be able to run this, right? So this is a normal subquery which is not dependent on anything. But now in this case, whatever we have, if I just take this subquery, if I take this subquery, will I be able to run this independently? I will not be able to run, because you can see, okay, first of all, I will remove this two froms. Okay, I will just show you that it is we are not able to run, because you can see we are dependent on the customers table. This customer ID we want to match from customers table. So this is not independent subquery that we run it. So it is called as correlated subquery. I'll write it, correlated, right? This is called as correlated because it depends on the outer query. And if let's say your customers table, just I am giving you idea, your outer query, that means customers table has 100 records, then how it will run is, let's say the first the customer ID is 1, 2, 3, 4, up to 100, right? I am talking about, let's say, customers table. So it will say select star from customer C where not exists this. That means first it will check this record, right? First, it will check the first record in the customers table, and it will see select star from order so where O dot customer ID equal to C dot customer ID. That means it's checking whether this one, right, is present in the orders table or not, right? That means for every row in the outer query, this inside query will run. So if you ask me initially, if the outer table, that means the customer's table has 100 records, so initially for one, this query will run. It will check whether one is there in orders or not. Then for two, it will again check. That means if customer's table has 1 million entries, this inside query will run 1 million times, one for each row of the outer query. I hope this is clear. So it will be mostly not that performant, because inside query will run many times. If this outer table is very, very big, then this can be a huge performance impact, right? So it's not that this query is evaluated first and then done, because if you see, right, in this case, this inner query is just running one time and it is replaced with the answer for this, and then this outer query runs. But here it's a totally different thing. It sees, or it checks the first value in this table and then run this query to check whether this is there in this orders table or not. So then it checks the second value in this order customers table, right? And then it checks whether okay in orders we again have two or not, like that. So this is that's why it is called as correlated subquery because it's related to the outer query. It is dependent on the outer query, and for each well or row of the outer query, this inner query runs once, right? So I hope you can understand that. So what we are trying to say, select star from customers where not exists. So how this will work? If customer says 100, it starts and then it sees whatever is not there. And how does not exist work? If this does not return anything, right? If this does not return anything, then not exist evaluates to true, right? So there are two things: exists, and not exists, right? So exists, I mean, if we would have given exists here, and if there is any value here, if it returns you anything, that means if this query returns anything, so it does not matter whether you say select star or select one or select uh, Sumit, right? Whatever, doesn't matter how many columns, how many rows, but if this returns you something, then exists return true. And if this returns something, not exists return false. Because not exist negates that. Just like null and not null, where this is null or where this is not null. So if this returns anything, then not exist returns false. Right? So that means if this does not return anything, that means if this is not present in orders table, this not exist will return true. And if it is true, we show the details from the customers table. I hope this is clear. So it doesn't matter how many rows in this is returned, how many columns are returned, right? So select one or select star or select order customer ID, whatever, doesn't matter, right? Because whether it returns something or not, that's what we are talking about. If it returns something, the value exists. If it does not return something, value does not exist. As simple as that. So I hope you can understand this and this should be easy for you to understand. So this is called as correlated subquery. And you can see we are getting these 30 records. But how it would have worked for each entry in the customers, this would have been called. Right? I hope we are good here. Okay? So I think you understood all the four ways of solving this, right? You understood the subquery approach where the subquery is executed first. Then you understood the left join checking on the for nulls on the right side, right? Then you understood this except keyword, right? Which is more of a set operation, just like a minus, which is there in first table but not in second, right? And then you also understood this correlated subquery with not exist thing, right? That means something which is not existing in the orders table, right? But this inner query is dependent on the outer query. So for each value of the outer query, this inner query runs once. And that's how we are doing that. But correlated subquery would be not performant, right? If you ask me whether this subquery is more performant or correlated subquery, I would say the subquery would be more performant. But sometimes databases internally optimizes things because they know what you are trying to do, and they would just do it as if there is no performance impact, right? But ideally, if you see it logically, this is not that efficient, the correlated subquery. But you should know that. And as part of our tougher interviews, definitely they can talk about correlated subqueries through subqueries. Now we will take a slightly modified version of that problem. So earlier we said customers who have never placed order. Now I want to find all the customers who have placed at least one order. It's just a negation of that ideally. So all the customers who have placed at least one order, now we will try to solve this. Same scenarios, everything, and I will not take much time for this. So what I will do, let's say the first approach using which we solved that customers who have never placed order, right? I will take this. So you can see select star from customers where customer ID, right? Where customer ID, instead of saying not in, I can say in select order customer ID from orders. That means I want to print only customers which are there in orders table. I hope this would make sense, right? And if I just take this, this should give me all the customers which are present in the orders table. So let me just show you that. And I get 12,405 such customers. How much? 12,405. I mean, let me see how many entries were there in my customers table. Select count star from customers, right? I have 12,435. And see, customer says 12,435 rows, and our query was giving 12,405. That means it's saying these are the customers who have placed at least one order. And you remember in our last session we understood there are 30 customers who never placed any order. So customers who never placed any order plus customer who placed at least one order should be equal to total customers, of course, right? So if you add these two, we should get this number, and that's what is happening. So you understood this query is running fine, and I am able to get all the customers which are present in the orders table. That's great. Now, how I solved it the other way using left outer join, right? Now, instead of doing a left outer join, I should be doing an inner join. I will quickly do because I want only the matching records. I mean, I want records in customers table which are there in orders also. Matching only, right? So using inner join. How do I do that? Select whatever from customers C uh, inner join orders O, right? Orders O on C dot customer ID equal to O dot order customer ID. Customer ID, right? So now this part I have to write. So I want only the matching records. Now let's say if one customer has made multiple orders, that will match multiple times, right? So if there is one, let's say 101 customer ID on the left side, and on the right side we have 101 and 101 coming two times. Uh, in customers, this is the customer ID. In orders, this person has purchased two orders, then it will come two times, isn't it? So it will this one record will match two records here, so we will get two entries, but we want only one. So we can say distinct of distinct of customer ID. And since customer ID is only in customers, but if we even want to say C dot just to specify that this is coming from my customers table, it's fine, right? Whatever you feel. So select distinct customer ID from customers C inner join order. So on C dot customer ID equal to O dot this. So let me see this. What does it give? And it gives me 12,405 records. 12,405. I hope this would make sense. I am getting all the customer IDs who have made at least one transaction. So inner join I have used. But this would have given me, or it could have given me duplicate records. That's why I basically use distinct, right? For example, if I would use select star here, we will get more than 12,405 rows. You see this. So we are getting more than 50,000 records, right? So that's where I am using distinct customer ID, right? Okay. Now, what was the other way which we used? So we have used subquery, we have used a join using set operations. Set operations. So, right, I use this query to say I want all the customers which are not there in orders. But I want now I want to say I want all the customers which are there in orders also. So it's like intersect, right? Intersect all the matching records, right? Just like when you make a Venn diagram and only something which is there in both, right? So intersect. That means something which is there in customers also and orders also. So this will give me all the matching records, matching customer IDs basically. So you see, it will again give me 12,405 records, right? Using intersect. I hope this is clear, right? Just have a look at the three approaches we have used till now. Now, the last approach, we will again do it using a correlated subquery. So, I will say correlated subquery. That means inner query is dependent on the outer one. Select star from customers C, right? Where, I'll write it here, where exists, exists. That means if something exists in orders, I want to print the record from the customers table, right? I'm just checking if it exists in the orders or not. So what I have to say, select whatever, right? Doesn't matter. From orders O, from orders O, where O dot order customer ID equal to, that means C dot, we have to say C dot, right? I'll just write it here, where this C dot customer ID. That means we might be checking a certain customer outside, let's say customer ID 1. So it will check whether this customer ID 1, so it will replace it with 1, whether it is there in the orders table or not, right? If it is there, then it will print the record from the customers. That means customer ID 1 along with all the other details will be printed. So for each value in the, or for each row in the outer query, this inner query is going to run, right? That's how exist work, and it will again return true or false. If this returns true, that means if this where condition is true, that means we want to display the record from the customers table, else not. So earlier we used not exist, right now we are using exist. And if I just run this, this should give me 12,405 records. I hope this is clear. So we have seen all the four approaches again just to get the reverse condition. That means the customer has placed at least one order. Earlier we did customer never placed any order. Now customer placed at least one order. So I hope you would be clear with this. Okay. So let's now dig more into the subquery part. So let's say we want to find average number of order items in each order. We need to find average number of order items, right, in each order, right? And also we need to find average order amount, and we need to find average order amount. You'll understand what I'm trying to say. So consider we have this order items table. I'll just show that. Select star from order items, right? Now you see that let's think that you purchased or you placed a order. The order ID is 2. Order ID is 2, right? And as part of this order, you purchased 3 items. 3 items you purchased, right? And let's say in these items, one of this you purchase a laptop, in another you purchase a mobile. I mean, you purchase a laptop, mobile phone, and let's say charger. 3 things you purchase as part of order ID two, and you have made a 3 items are there as part of this single order. In Amazon, whenever you purchase, it's not that you will order just one product. You can order multiple products like in same order. So that's how, let's say, this is there. Now we have order items table to indicate the same thing. So for example, if you see this, the second, third, and fourth row, these are related to order 2 only. So these 3 are related to order 2. That means as part of order 2, how many items were purchased? 3 items. 3 items, right? And the product IDs are 1073, 502, and 403. That's fine. And the total price for this is 199. This is 250, and this is 129. That means if I have to calculate, if someone asks me as part of order 2, right, how many items were purchased? So total items is 3 in this case for this order 2, and total value or total amount or order amount for this is, total order amount for this is 199.99 plus 250 plus 129. This, so roughly if I do 450, 550, 5 uh, 4 1 minute, 450, 550, 580, roughly 580, right? I calculated, summed up these 3. So if someone asks me as part of order 2, order ID 2, how many items were purchased? 3 items. Total amount of this order, like what was the total uh, amount of this order, right? It is 580, because these 3 items costed 580. I hope this is clear. So first, if I have to calculate the average number of order items, then I should get a state where I should get that, okay, I should have an intermediate state where I get order ID, number of items, right, and total or order amount, right? For example, if you see order ID 1, if you see this order ID 1 has just one single item, so 1 comma 1, so assume this one is below this, right, for this, and let me press a tab only so that you do not get confused, and order amount is 299.98. In round figure I will write 300 just for my easiness. Order ID 2, and you see that there were 3 items as part of this, right? 3 items, total items, and total amount was 580. 580, right? And same way we get it for all the order IDs. That means for each order ID there should be one row. And now if I have to calculate the average number of items sold per order and average order amount, then first I should have this kind of a table, intermediate table. Then I can do a average on this and average on this. I cannot directly do a average on this column here, because first we need to bring it to order ID level. That means for each order ID we should have one single row, right? So let us first get this structure. How do I get this structure? I can say select whatever from this, right, autocomplete is a problem here. Select this from order items, right? What I can say, from order items, group by group by, what is that? I need to group by based on order item order id, this, right? Order item order id, order item order id, and the moment I put it here, I put it here also, right? Comma, count star will give me total number of items inside this order, right? Total number of items inside this order, comma. So I will just write it in a new line, comma, and I want total amount also, so I can do sum of order item subtotal, sum of order item subtotal, right? That's what I am doing. Now I can give it a name as, let's say, as number of order items, and this I can say as order amount, as order amount from order items group by this. So let me see if this is giving me whatever I want or not. And this I can give as order id, just giving better names so that it becomes easy for me later. So I want this intermediate structure first, and you can see I get to know order id 1 has just one item inside that, total price was this. Order item 2 has three items as part of it, and total amount was this. Order id 4 has four items inside that, total amount is this, and so on, right? So for each order there would be just one entry now, right? You understood. Now I have to get the average of, I want to understand that, okay, on an average how many items are sold per order. So I want average of this, and I want to understand what's the average amount per order. I want average of this. How do I get that now? So I can write select, select average, select average, right? Select average, and I can say number of order items. So you can see this column basically I want. Select average of this, comma, comma, average of what? Average of order amount, right? Just write it in this new line. From from where? From this intermediate structure that we have, right? But this table was not there. I mean, we created it, right? But we have not created it as a table, but we can just use it as a subquery now from this particular subquery. So whatever is the result set of this, you think that's like a temporary table. It's not like a temporary table. There is no object created as such, but it's like some temporary structure which is there. No, actually object is created, but this, I mean, kind of this executes first, and you think that it is as if this is one table, right? And whenever we are using a subquery as part of from, right, then we have to give it a alias name. Just like you think from orders table, assume that this is from table 1, then we have to give alias to this table, right? So let's say I give a alias as x, anything I can give. Why this is required? So that later while selecting columns and all, you can just say x dot something and all, right? So it is mandatory to give this alias whether you use it or not, right? And I give it some name as, let's say, as average order items, average order items, and I say as average order amount, avg order amount from this table, right? So you see this way, and let me try running this, and you can see this. Roughly three orders items are sold, or whenever someone orders, roughly they I mean add three items to that, and roughly each order is of this much value, 597, right? We could not have got this directly. We could have only got it using this structure. First we need to get the data to this form, and you see how cleanly we understood. So, I mean, if you read the query like this, it becomes hard. But the moment you solve the subquery first and then you use it, then it becomes easy, right? But if you start reading it from left to right, it becomes difficult. That means top to bottom becomes difficult. But if you try analyzing the subqueries first, because ideally subqueries are executed first, right? So if you first understand what does this do and think it like a table X, right, then this becomes easy for you to understand, right? I hope this makes sense. Now let me just take a variation of this. Let me take a variation of this, and what we have to do is find average number of orders placed by each customer. Very similar to this, uh, find average number of orders placed by each customer. How do you find this? Very similar problem. I mean, we can very easily do that. So, which table we have to refer? Which table we have to refer? Let me see. Can orders table help us out? Select star from orders. Okay, this orders table is there, and we have order customer ID. Now, if this order customer ID, let's say 11599, if it is coming three times, if 11599 is coming three times, that means this person placed three orders, isn't it? So we need to just work on this orders table. So how to find average number of orders placed by each customer? How do you do that? So first, if I get this kind of structure, that I get customer ID, comma, number of orders placed. For example, customer ID 1 placed 4 order, customer ID 2 placed 3 orders, customer ID 3 placed 7 orders, customer ID 4 placed 1 order, like that. If I get this kind of structure, then it becomes easy for me to find on an average how many orders each customer places, right? So first let's get this. How do you get this? So I can say select whatever from, this is uh, from orders, from orders, right? What I want, group by group by order customer ID, order customer ID, right? Now I put it here, comma, comma, count star as total orders, right? If I run this, I will get how many orders are placed by each person. So you see, customer ID 11599 has placed 5 orders, customer 256 placed 10 orders, like that. So this is what we got. Now, if we have to calculate average number of orders placed by a customer, we can say select average, right? Average of total orders, of total orders from from which table? This table. And how we get? Using this query, right? This one. And let me give it some name as alias as X. Whatever you give more meaningful name, but I'm giving, since this is not used in my this select. So if I just run this, I get okay. Uh, Roughly each customer places around 5.5 orders, right? Each customer has placed around 5.5 orders, around 6, you think it this way, 5, between 5 and 6, right? I hope this makes sense. So with this, you would have understood a little more about subqueries. And remember, whenever we are using a subquery as part of from, then you have to mandatorily give it some alias name. If I remove this X, it will not work. It is not going to work. But earlier we have used subquery, uh, right? And we have used as part of, let's say, where clause, like a condition. In that case, you do not have to give a alias. In that case, you do not have to give it a alias. You have to give a alias name to this subquery when you are treating it like a table, right? From clause, from, or even when you are using it in join, right? As if it's like a table you are using from or join, then you need to give it some alias name, otherwise, not required. I hope this makes sense. So with this, I hope you would have understood little more about subquery. Now, let's say what we have to find out. I want to find out big orders. So I will first copy this here, and I understood this is what I am getting. I want to find big orders. Big orders in the sense that, I mean, as the name conveys, that okay, it's bigger than others. That means it's bigger than average, right? That means if some order has to qualify for it, that means all the orders where order items are order items are more than average, right? Are greater than average order items, average order items, and and order amount, right? Total order amount, and I will just write order amount is greater than average order amount. Average order amount. So, as part of analysis, I want to find big orders because management has asked me to find which are the big orders which were placed. Now we know the average also. So, anything more than average is bigger. How do we approach such problems? So very first thing is we would have to calculate this average order items and average order amount, isn't it? The very first thing that we would have to do is find out this. Okay. So how to find out this? We have this query. We have this query. Now this query, through this query, we can find out this particular thing: average order items and average order amount. Now, what is our actual table? Order items. Our actual table is order items, right? So, what I want is the other one, what I want is I want to even get the, let's say, some structure like I want something like, okay, order ID 1. There are three items which were there as part of it, and total amount was, let's say, 500. Order ID 2, total 5 items were sold as part of it, total amount was 800. Like that, also I want. And I want even this kind of structure where I understand that averages, that average is, I'll just take this. Can I copy this? 1 minute. Copy row. Let me just see. Okay. So this is average order items, comma, average order amount. AVG order amount. Right? You think this is like this. So this is one kind of table that you have, let's say, and the other table would be what I need is the, if I tell you, would be, I'll just tell 1 second. Select order item, order ID, comma count star, sum this from order items group by this. Okay. Other table that I need is this one, right? This kind of structure I need. So I will just take few rows. Probably some rows I will take. Uh, okay, it's hard to get, but if you see, this would be 1 comma 1 comma, that means order id 1, number of items sold 1, and let's say I just give a random 299. Order id 2, uh, and total items sold were 3 as part of this, and total amount, let's say 580. I'm just writing it in round figure for my easy this thing. 4 comma 4, right? As part of order id 4, we have 4 items, and we the total amount is 700, like that, right? Like this I want one structure, and another is this. So I will just even give the names, order id, and this second column is number of order items in this num order items, and the third column here is order amount. Now you just think that if you have this structure and this structure, two structures, as if this is table A, table, let's say A, and this is table B, right? Just think of it. So this particular table has just one row, right? Only one row. Two columns are there, one row. And this particular thing has how many rows? Equivalent to number of orders. Let's say if number of orders are 500, then 500. It's equivalent to number of total orders. And I believe in our the current data set, it's something around 67,000 or something, but that's how it is, right? So for each order, there is one row. Now, given these two tables, this table with 67,000 rows and this table with one row, can we tell which are big orders? Can we tell which are big orders? I mean, we can easily tell given these two structures are there. We could do a join between these two, and now you will say, okay, what is a matching column? Let's say there is no matching column. We say a Cartesian join or the cross join, right? That means this particular row is joined with every row of this table, and that means if we join these two, the output will be something like this comma, and these two is also added, right? I hope you can understand easily what I am trying to convey, right? And if I talk about the second row, this is also joined like this. This is how this particular row will be joined with every row of this table. And then it becomes very easy whether you can see this one, right? So, I mean, let me write the column names also. The column names here now, this comma, uh, these, isn't it? So as if this is one table. So if you think this is like a table and you have to tell which are big orders, you just have to say this order amount greater than average order amount. So here it is 299. Is it greater than this? No. Here it is 580. Is it greater than this? Yes, it is. So this particular condition qualifies, but there is one more condition, that number of orders. As part of this, we have 3, and as part of average items, we have 2.9. So, yes, this particular order qualifies for a big order. I hope you can understand. So, we have to get this kind of a structure, right? And before that, we have to get this and this. So, that's where we will be writing multiple subqueries to get that. So, you know that this particular thing we are getting using this, and let's name it as B. Let's name it as B as whatever we mentioned, isn't it? Okay. How I get this particular structure? The first one, this. Okay, so this structure I would say as B. This is this one. Let me just run this and see whether we are getting this average or not. Okay, we are getting this, and this one is what we said is B. Let's say table B. Before that, we want this. How to get? I take a inner part of this, which is this one, which is this one. Let me just run this and quickly sort this out. Okay, so if I have to just take this part, what I can say, if I have to make it as a subquery, I can take this and make it as A. As simple as that. So we have this subquery and this subquery. So this A gives me similar thing like this, and B gives me similar thing like this. Right? Now I will say, I mean, the outer query will be select whatever from, right? I will say select star from. I will not worry. Select star from. Let's say as if this is table A, and then what I have to say, inner join, or I can just say a join, whatever. I can just say join this table B, and I would not give a condition. Let's say I will not give any condition. Then what it will give me? I mean, it will be a Cartesian join. This row will be joined with every row of the other table. So you can see this A, and of course, I have to put it as part of this. 1 minute. I have written multiple this, right. So this I will give X, and this I will make as B. Right. So whenever we are mentioning it as part of from, let's say here you mentioned it as part of from, then from, let's say, this table, then I have to give alias X, whatever name. And even if when I have to say join this table, right, as if this is like a table. So you see this, if I'm clicking here, you see this entire thing, as if this is like, let's say, employees table or whatever. I have to give alias B. So you can see this is multiple subqueries we have written. So if you see, this is one subquery and this is another subquery. And if I run this, so you can see order ID, number of order items, order amount, and average. So whatever structure I was telling, we are getting that. You can see this. Whatever structure we were saying, we are getting. Right? Just have a look. I hope this is clear. But now, which of these are big orders? We understood that we have done a Cartesian join or cross join. That's fine. Each row of this table, second table will be joined with every row of the first table. That's fine. Now, we just need to have a check on clause or where clause, whatever we want, that this number of order items should be greater than average order items and order amount greater than average order amount, right? So we can say on or where, whatever you want, it's fine. Number of, what is that, number order items greater than what, average order items, avg order items, and order amount is greater than average order amount, avg order amount, right. So if I take this and run, this should only give me the big orders. Okay, I have not put it there. 1 minute, control Z. uh, First I will just take this and put it like this. Now this should work. Okay, and you can see I am getting 25,773 records. And in all of this, you will see whatever columns you want, you can select that. Now, you will see that, okay, all the orders where number of order items and order amount is greater than the average ones. So these are big orders where it's more than the average, right? But you can see what subqueries we have. We have this subquery, right? And we have this subquery. You can see we have this again as a subquery. So multiple subqueries we have written, and this finally we have wrapped it around. Finally, we have wrapped it around. Now you see we have given alias. If you want, you can say select a dot star comma b dot. That means as if this you are referencing a table with the name A and referencing a table with the name B. Think it like that. But you will acknowledge one thing, that the more subqueries you will have, the difficult it becomes to read the query, because our habit is that we read select star from and then we try analyzing this, then analyzing this. But the best way to understand or read subqueries, if I would say select, I mean, if I create a template, something like select star from, right? Uh, A, select star from A, join B, right? And then we have this on this condition, right? Now, if you see this part is A, we are trying to think as if it's a table. So all the result set of it, think that it's like a table A. The output of it, think like a table B, right? And on this condition. So if you try to think like this template, and then you analyze, okay, what is A and then what is B, you will be able to understand it very easily. But if you try reading it from top to bottom, it becomes difficult for you to interpret this, right? So here you have mentioned this on. You could have wrote where also. You just see this should work the same way, and we got the same results. So generally, how what's the difference between when, where, and on? On means while doing the join itself, it will try to do the join accordingly. It will filter there itself. But where is something which executes later. That means first the join is executed, and then from the output of join, we are using a where condition to eliminate some records, right? So ideally, in this case, on would have made a better choice, because I mean, while doing the filter itself, based on these conditions, the join will be performed. But there is no matching condition we are putting. That's why we are saying it's a Cartesian product or cross join, right? I hope you can understand that. Just have a look what we have done. So, if you see what we have done till now, I mean, where exactly we have used inner queries, right? Sub queries, where exactly we have used it along with, if you see from and then subquery we have given. So I'll just write from. We have used along with join. You can see join, and then we are writing a subquery, right? Join we have used along with, other than that, let me just see up what we have done. If you see, from here we are using along with from, okay, and from, so mostly we are using along with from, okay. We have used along with where also. So if you see this, where customer id in, right, as part of the condition where clause, right, as part of the where clause also we have used. I hope you can understand that, okay, we have used it at these places. Just have a look at it. You should be able to understand this. Okay. Now, let's say I want to rewrite this. I want to rewrite this. I do not want to do a join. I do not want to do a join for this. Then how can I approach this problem? How can I approach this problem? So what I will do is I will let's say I will say select whatever, right, from, you know that my main table is order items only, right? Order items. Okay, 1 minute. Group by, what? Group by what? Order id, right? Order item order id. I'll explain what I am trying to do here, right? Group by order id, and I will just take the same here, uh, comma, count star, as num order items. uh, I'll just take it in a new line, and I will do a sum also, which I mean I'm repeating whatever I have done. Order item subtotal, and I give name, let's say, as order ID, uh, as I can say num order items, and as, sorry, as order amount from order items, uh, group by this. So I mean, if I run this, if I run this, 1 minute, select order ID as order ID, comma, count star as num order items. Okay, I have written it two times, my bad. Okay, so you are getting this. Now, if you logically think from this, I mean, you have got this group data for order ID 2, 4, 5, everything, group data. Now, these are multiple groups, and how many such groups are there? Equal to number of order IDs. For each order ID, one group. Because that's how we have grouped it, right? That's how we have grouped it based on order IDs. Now, out of these groups, we want to select only groups which meet our criteria. And criteria is that this number of order items should be greater than average, order amount should be greater than average. That means somehow we can use a having clause if we want, right? So I just take this, right, and I will build on this query now. I mean, instead of having a different table doing a join, I will rather use, let's say, a having clause. Having this count star greater than, having count star greater than average number of items, right? How do I calculate this average number of items? Have we calculated above? You can see this, right? So this gives me average number of items. Let me just see. I will remove amount, uh, comma, this sum total from this. Just a second. From order items, right? Group by this. So I'm just checking it 1 second. X. Okay. So if you see, this particular query is giving me average order items, right? I just borrowed it from my previous code itself. So can I directly write this where having count star greater than, and then I just give this, right? I just gave this, but I have to write it as a subquery here, so I can just say, I mean, whatever, I can give this. But now, since I am having it as part of having, I do not have to give it some alias name. It's fine, right? This alias, why it was given? Because I used it as part of, if you see, from. So if you see this, if I just click here, this is one subquery, and it's from as if some table and I have to give some alias. But now this one, this subquery, whatever I am giving, is along with having clause like a matching condition. So I do not have to give it a alias. That's fine. So if I just run this, if I just run this, I am able to at least get orders where number of order items are greater than average. So you see the average was 2.99 something. So all of these are more than that, like 3 or more, right? But still I have not filtered based on order amount. Still I have not filtered based on order amount. You can see the average order amount was 597 something. 449 is also coming. 549 is also coming, like that. So the other condition was having count star greater than this, and then and condition, and order amount, this order amount greater than, order amount greater than, and again I can write a subquery. What was that? uh, I'll just take this, right? Order amount greater than, and I will remove this part. uh, Sorry, I remove the other part. So I have to say select average order amount, this one, from this. Okay, this seems to be fine, right? Now if I take this entire query, see, I would not say that whatever I'm showing is the optimized thing, but I'm trying different ways that where exactly we can use a subquery, right? So you can see this now. Now, if you see as part first, we got all the groupings. That means each order is having these many order items, and this is the amount. After that, we are eliminating some of the groups, saying, okay, this does not fulfill my criteria. And how do I do that? Using having clause, right? So now I'm getting order items which are more than, like, having 3 items inside that, and 3 or more, and this is more than 597 because that's the average, right? And you can see this. Now, how this query is executed, the inner queries are executed first. So if you see, this will be executed, right? And then this will be executed, right? And then finally, this outer query is executed. I hope this is clear. So in the end, this query will become something like, this query will become something like having count star greater than, uh, having count star greater than 2 point this thing, because this is calculated, and uh, and order amount greater than, order amount greater than this one. So this is how this query will be becoming like, because the inner queries or the subqueries are executed first, and this is how this will become, right? And then this will be executed. I hope you would have understood this perfectly fine. I have taken more time to explain because I want to explain each detail to you. So, whenever you are reading this query, and if you start reading from here, right, you will get lost. First, start analyzing the subqueries, understand what they are doing, right? And then you think of a query something like this. This will make more sense to you. I hope this is clear. So with this, you would have got a lot more clarity on this, and you have seen two approaches: one using join and one using having clause, right? So that, I mean, we have now used it with from, join, where, having, all of these places. You kind of get an idea that whenever you are using it as part of from or join, then you have to give it a alias name. Whenever you are using it from where or having, no alias is required for your subquery. And subqueries are executed first. But a correlated subquery is the one which is like a different thing. It depends on the outer query, and for each row in the outer query, the inner query is executed once, right? So correlated subquery is different than a normal subquery. I hope this is clear. Now we will do some more examples so that we are very comfortable with it, because I mean, when we talk about SQL medium to hard problems, mostly you will find subqueries within them, right? So let's again do it. Now you remember once we talked about the customers table also in last to last session, I guess. Select star from customers, right? Sorry, orders table. And in orders table, what we understood was that how many orders are placed by each customer, right? And we also understand average amount of orders placed by each customer. And here was the query for that, right? Average number of orders placed by each customer. So for that, first we calculated this, right? If you remember that how many orders each customer places by having this as the group by order customer ID and count star. That means if 11599 is coming three times, that means this person has placed three orders. As simple as that. So you can see. And then we did a average on top of it. Select average total orders, right? We did an average of this. That means sum of it divided by the count. And that's how we got the average. If you can recall, if I run this, we get 5.5. That means on an average, each customer places 5.5 orders, right? Okay. Now the question is, we want to find premium customers. We want to find premium customers. And premium customers are the ones who, I mean, purchase more than or who order more than average number of orders, where number of orders are greater than average number of orders. And average number of orders is, let's say, 5.5, right? So how to approach this? We can say select star from select star from orders, right? Select star from orders, or let's say select whatever from orders, right? Group by group by group by, we will say order customer ID, order customer ID, and the moment I place it, I say this comma count star. That means I am trying to get how many orders each person is placing, first of all, and then using having I will filter those, right? So this will give me, let's say, uh, one record for each customer, right? One record for each customer. Let's say if there are 12,000 customers, we will get 12,000 records here, right? That okay, this customer ID purchased 5 orders, this customer ID purchased 10 orders, like that. Now using having, we can basically filter out what groups we want, right? Having count star greater than, you remember, count star greater than this 5.5, but we cannot hard code, this value could have been different. So we can basically write this as a subquery and put it like this, as simple as that. And this will give us all the customers who are premium customers. That means they have placed more orders than average number of orders. And you see, I'm not so for this subquery, if you see this one, this is like from, and I have to give alias. But if you see this subquery again, which ends here, this is as part of having clause, and we do not have to give alias, right? It's fine. If we run this, if we run this, we should be able to get the answer. And this gives us 5,954 such customers. And you see, count star will be more than 5.5 here, right? Because these are premium customers. So this was a query which was very similar to the one we wrote in the last session. I hope this should be clear, right? Just have a look. I believe you should be able to understand this without any issues. Now, let's say we have this orders table. Select star from orders. And as part of this table, I want a fifth column. As part of this, I want the fifth column, which is average amount of orders each customer places, which is like 5.5 we calculated. How do we get it as part of the select? Right? So as part of select, in orders table, I want one extra column which indicates which indicates the average number of orders number of orders each customer places, right? There is, let's say, a requirement we want to do that. How do we approach that? I can say select star from orders, right? Generally this is how I write, right? Select star from orders. But now, instead of star, I want one more column, comma, one more column. What is that column now? I want to get the average. And I think we have done above that. This is how we get the average. This is how we get the average, isn't it? So you can see this. You can see this. This is how we will get the average. So we can write it as a subquery. We just wrap it like this, and I can give a name as, if we do not want to give, it's fine. I mean, I will just show that to you. I'll just show that to you. This will work. But this name, you see this entire thing will be the name, right? So better give it some name. You see this. So I can say as AVG orders, right? And if I run this, I get this thing. I get this. Let's say this was a requirement. So I want to showcase that as part of the select itself, we can we can write a subquery. So in the previous session, we saw that as part of what all things, these. Now I have shown you that as part of even select, we can write it. You can see this. We have written, right? I hope this would make sense to you. Just have a look. Okay. So now let me create an employees table. You see, I'll create an employee table which has employee ID, name, and salary. And I will insert few records. I'll insert a few records. Done. I'll say select star from employees. Select star from employees. Okay. We have these 5 records, let's say. Now my problem statement is I want to find employees with above average salaries. Find employees. Okay, I will write in the next notepad, right? I'll just take this here first of all. Find employees with above average salaries. First of all, what will be the average salary? All these salaries divided by, I mean, some of these salaries divided by number. So 60,000 plus 75,000 plus 50,000 plus 80,000 plus 45,000 divided by what? 5. That is the average salary. So if I have to find the average salaries, select AVG salary as average salary from employees. This will give me the average salary, which is 62,000. So I want to find all employees who are getting more than average salary, who are getting more than 62,000. How do I build this query? So I can say select star from employees, select star from employees, where salary greater than and I can write this as a subquery with salary greater than this, right? And since I'm writing in where clause, I do not have to give a alias. That's fine. So if I run this, I should be getting all the employees who are getting more than I mean, who are getting more than the average salary. I'll just show that to you. And we have two employees who, Sneha and Priya, who are getting more than the average salary. That means they are the good earners. I hope this is clear. Just see how simply we have written this, right? Okay. So with this, I mean, it's a good point to time to explain that the types of subqueries we have. So there are uh, three main types of subqueries, right? There are three main types of subqueries. Number one, a scalar subquery. Scalar, as the name says, one value, just one single value we are getting, right? So, for example, you see this. This one is a scalar subquery. That means it return one row, one column, a single value, right? So I will write it a subquery that returns just one row, and one column, right? One row, one column, single value it returns. So in general terms, a subquery that just return one value. So in general terms, a subquery which returns just one value. I hope this is clear. So you can see this one is a scalar subquery because if I run this, I just get one single value, isn't it? One value. That's it. One column, one row, single value. So where exactly we have to use? I mean, so whenever we are comparing it like equal to, greater than, less than, right? At those places we should be using a scalar subquery because here if we would have got multiple rows or multiple columns, how would this greater than work or how would a equal to work, right? So you understand that this can be a problem if let's say you are not using the right operator here. So if you are using greater than, then of course it expects just one value from here, right? You can't return multiple values or you can't return multiple rows. It expects a scalar subquery here. So if it is greater than or let's say less than or equal to, in such cases, it is comparable to one value itself, right? Not more. I hope this is clear. So now let's talk about the next type of subquery, which is either multiple rows or multiple columns. Multiple columns. These are logical. I mean, someone else might say it with some other name, but logically you think it this way: scalar subquery which return just one value, or there are subqueries which return multiple rows or multiple columns, like that. So this is a subquery that returns multiple rows or multiple columns or both. I mean, the name is itself intuitive. So, for example, if you see this, when we are using as part of from, right? When we are using as part of from this particular subquery, this is returning multiple rows and multiple columns. If I run this, what will I get? You see this? I get multiple columns and multiple rows. So such kind of subqueries you would write as part of from or join, right? Because it acts like a table. It acts like a table, isn't it? Multiple rows, multiple columns, can be anything. So if you see this, mostly you use as part of having or where clause scalar subquery, but multiple rows you use it as part of. So I'll write it where having, right, like that. But this one you use it as part of from and join mostly. See, again, this is not something which you will find in a document. I am talking with a logic here, right? Might be there are exceptions, but generally if you see it will be this way. So if you see someone somewhere, we would have used joins and all, right? Uh, so you see, as part of having, we have used a way that it should give us just one value, having greater than, right? uh, and join, I will see join, you see, this returns two columns, you can see this, right? And from, you see, this returns multiple columns and multiple rows. I hope we are good here. So you can just relate to it, how exactly, whatever way you feel. But sometimes a subquery just return one value, sometimes it can return multiple rows and multiple columns, right? Now, the third kind of subquery is the correlated one. Correlated. Now, this is very different because generally, a subquery, if you ask me, uh, a subquery gets executed first, the inner query, and then the outer query is executed, right? But a correlated subquery is very different because this is dependent. This is the subquery which is dependent on outer query. So, for every row in the outer query, this correlated subquery runs. So, correlated subquery, if I have to say, uh, a subquery that depends on the of results of the outer query of the outer query. I hope this is clear, right? So I will show you one more example now that will clear a lot of confusions related to correlated subquery. I will drop my employees table and recreate it. It has department ID also. It has department ID also. That's the difference, right? So drop table employees, I will say drop table employees. Okay. Now let me recreate this. Done. And I will say select star from employees. Okay. You can see this. We have department ID also as an extra thing. Now the problem statement we want to slightly change. We want to change the problem statement. We want to find employees earning more than average salary in their department, right? So I'll just put it first of all here. Okay. And what I want to find? Find employees earning more than average salary in their department, right? For example, if you see, in department ID 1, what is the average salary? So 60,000 plus 50,000, 1 lakh 10,000, 1 lakh 55,000, right? So 1 lakh 55,000 divided by 3 equal to 55,000. If I have not done any, equal to 52,000 roughly. Roughly, I am saying, right? Average salary for department 1 is 52,000. So if we get something like department ID comma average salary, let's say 52,000, right? Department ID 2 comma average salary for that, average salary is 75,000, 80,000, 1 lakh 55,000, and 55,000, 2 lakh 10,000. So it is, I guess, 70,000, right? Same way we will have for department 3 some average salary, let's say 80,000, let's say. We have to first get this, right? That where the first column is department ID and second is average salary for that department, right? Average salary for that department only, right? Now, if we have this kind of a table structure and we have this kind of a table, which is our source table, and then we join this. Let's say we join this department ID with this department ID here, so that we get one final table. So you consider this is one table, this is another table, and we want to get a table where we have this also joined, right? Let's say department ID 1 52,000, 52,000, 52,000. Department ID 2 70,000, right? 70,000 and 70,000. Consider it like that. And this department ID 3, uh, 80,000, 80,000. If we get this kind of structure, then it becomes very easy for us to then see whether the 60,000 is more or less than this, right? But how do we get this? That's something which we will see now. I hope you understood what's the idea. So let's write a query now for this. So first, let me try getting this thing. How do I get? Select, select. I can say department ID, comma, what I can say, average salary as AVG salary from which table? Employees, group by department ID, department ID, right? So you can see this. If I run this, let's see what does it give me. It give me the average salary of each department, right? That structure which I was talking about. So this is basically 1 and 51,666. 51,666. And this is 2 and 70,000. 3, it is 67500. 67500. This is what it is. I hope this is clear, right? So let's form a subquery out of it. So I'll just take it. I'll take it here and let me create a subquery. I just enclose like this, and since I'll be using it as part of join, I have to give some alias name. Let's say D, some name I have given. Right now, before this main table I wanted, right? So I want to do select something. 1 minute. From what is the main table? From employees, right? From uh, employees, right? I give some alias, let's say E, join, right? It can We can just mention inner join because of course it will match. Inner join this particular table, let's say, considering we are getting department wise average salary, right? So this is one table, and think this as another table. So you see, the first table is this one and the second table is this one. So assume this we are referencing it with the name E, and this we are referencing with the name D, right? So select something from E, inner join D, right? Like that. Now what we have to give here, let's say I want to display what, let's say EMP ID, name, employee name, let's say, and salary. I can select whatever columns. Now, let's say from this, I want department ID, E dot department ID, what department this person is working, and let's say average salary. If there is a conflict in the name, then of course you have to mention E or D dot something, right? So department ID was in both the tables, so that's why I'm mentioning E dot, right? I hope this is clear. So let me just run this query. So you can see we are getting the salary and the average salary also. Now it's very simple what we have to do. I can just say where salary is greater than average salary. Salary is greater than AVG, right? Salary. As simple as that. So earlier there were 24 records. Now let's see how many records we will get. We are getting only 11 records. We are getting only 11 records. You can see this. and moreover we are getting duplicates. So you can see, of course, when we do a join, right, we can get multiple records. You know that very well. We can get multiple records. So let's understand this by removing this condition. So I was doing an inner join employees table. We have how many records were there in employees table? Let me just see. So select star from employees. Let me just see that we are having only 8 records, and this department ID we will be joining with the other one. But now we understand that when we are having this query, let me just run what exactly how many records it's giving. We are getting 1, 2, and 3. So all the ones are joined with 1, right? So I think what we missed out is when we did a inner join here, we forgot to give a condition, right? We forgot to give a condition, right? So let's rectify that. So on what we have to say, e dot department ID equal to d dot department ID. Now it should be perfect. So you can see we are getting 8 records only. We are getting 8 records because earlier it happened as a cross join. We forgot to give a join condition, right? But we identified that. That's fine. Now this is actual this thing, right? I'll just put it here. This one. Now as part of this, what we can just say where salary is greater than average salary, as simple as that. And we will get employees. These are the 4 employees who are having more than average salary for their department, right? So you see, in department ID 1, the average salary is 51,666, right? In department 2, the average salary was 70,000. In department 3, the average salary was 67,500. So it is comparing with their department only now. And these are the 4 employees within their department, their salary is more than average salary. I hope this would give you a lot of clarity now, right? Because we have taken a very step by step approach in order to understand this. Now, we could have even solved this using a correlated subquery. We could have even solved this using a correlated subquery. So, what I could have said, select employee ID, name, salary, and let's say department ID, right? I want this from employees E, right? From employees E, and I remove all of this where, right? So let me first of all show you the employees. Select star from employees, right? So now we have 8 records, and what I want for each record, it sees the salary and then it compares with the average salary. That's what I want. So that means I want my inner query to run for each outer query. My outer query would be this, right? So I just take this, right? Or I say, let's say, select star from employees E where salary is greater than. Salary is greater than. That means for each record, like for it sees first record and then it sees salary greater than, right? And whether if it is greater than that average salary, it will retain it, otherwise not. Now I have to write a subquery here, right? I hope this is clear. Now what I have to do is I can write the subquery. How I will write? I can say select. So basically, I have to compare with the average. How will I get the average salary for this department? Select average salary, select average salary from employees. I can say where department ID, select average salary from employees where department ID equal to E dot department ID, right? So how this is going to work is, initially it saw employee ID 1, name Amit, salary 60,000, department ID 1. Then it comes here. Select average salary from employees where department ID equal to, and then E dot department ID. What is E dot department ID? E is this outer table, right? This is 1. So select average salary from employees where department ID equal to 1. So this will be something like, the inner query will be select average salary from employees where department ID equal to 1, because this 1 is what we are getting from the outer query. And if I run this, what I will get? 51,666. So that means this will be then replaced with 51,666 for the first, right, this thing. I hope this is clear. So if you run this, we see the same results like we got earlier. But it again, for each row in the outer query, right, it will check against this condition. This inner query is going to run. I hope this is clear. And one more thing I will tell. Sometimes when we write long code and it's not indented properly, you can always select it and say view, not view, edit and format and beautify query. And you see, I mean, you get it in a more proper way so that you can analyze it better. You can analyze it way better. Just to let you know. So what I did is I selected this and then edit, right? Edit, and I said format beautify query. Just to let you know. By the way, now this is my correlated subquery, because if I just try running this inner query, it will not run because it is dependent on outer query. We are saying E dot department ID, right? I hope this is clear. But this entire thing works, and this is equivalent to whatever we have run earlier. Same result it's going to give me. I hope this is clear. So I will write correlated subquery. So with this, I believe that you would have got a pretty good understanding about the subqueries, and subqueries can be tricky if you do not understand them, right? So we have understood scalar subquery, which just return one value. That means one row, one column, and you can very well use it as part of the where clause and things like that, right? And then you understood about multiple subqueries which return multiple rows and multiple columns. You mostly use it as part of from and joins. And then you understood about correlated subquery, which is dependent on the outer query, right? So correlated subquery will, in a ideal case, if system do not optimize or if database do not optimize it, ideally it should take more time. But databases are smart, they understand that okay, what you want to achieve, and they internally optimizes the query in most of the cases. But not worry about performance, think that databases are smart enough these days. You write the query the way you feel it's best, and most of the times systems gives the ideal performance as if it's equivalent to that we have written in a performant way. So with this, I would end the session, and I hope with this you would have understood about subqueries. Thanks a lot.